Hello, we are from Group 5. We will present about our project, which is crane. So my name is Muhammad Hakim Azlan, and I will present about the introduction. Every day in heavy industries, scrapyard and post-forward millions of tons of raw iron and steel must be moved, which is low and highly hazardous task if performed manually. To solve the massive logistic challenge, industrial engineering relies heavily on electromagnetic cranes, which are specifically engineered to lift, transport, and pressurize these heavy ferromagnetic materials with absolute efficiency. The core magic of this technology lies in the fundamental relationship between electricity and magnetism. Unlike permanent magnet, they are always active, and electromagnetic produce a magnetic force only when an electrical current flows through its coil. When the current is switched on, the magnetic domains in the core align to create powerful temporary magnetic field, and the moment we cut the power, the magnetic field collapses to instantly release the load.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akhil bin Muhtaruddin Shubli. My matrix number is BE2030371, and now I'm going to continue with the problem statement and objective of the project. So the main problem statement in this project is the difficulty and safety risks involved in manually handling ferromagnetic materials such as iron and steel scrap in industrial environments. Worker may be exposed to the injuries caused by sharp and heavy metals objects during lifting and transportation process. So, although electromagnetic cranes provide a safer alternative, designing an effective electromagnet is not simple. If the magnetic force is too weak, the load may accidentally fall during operation. On the other hand, excessive current can cause the coil to overheat, affecting system performance and safety. Therefore, this project aims to develop a small-scale electromagnetic screen prototype that can lift and release metal objects safely, reliable, and effectively, while demonstrating the principle of magnetostatic. Next is the objective of the project. So there are three main objectives of this project. The first objective is to design and develop a small-scale electromagnetic crane prototype based on magnetostatic principle. Second objective is to investigate how electrical parameters such as current supply and the number of coil turns affect the strength of the magnetic field and the lifting capability of the crane. And lastly is to analyze the overall performance of the electromagnetic, including its lifting operation, releasing mechanism, and thermal behavior during use. Through this objective, we can better understand the practical application of electromagnetic theory in industrial material handling system. So that's all from me. Thank you.
Hello everyone, my name is Abdurrahman Amin Saif and my matrix number is BE2030001. In this video, I will explain the methodology, specifically the theory and system design of our electromagnetic crane project. The operation of this project is based on the magnetistic principle. The magnetic flux density can be expressed by the equation B equals micro Ni divided by L, where B is the magnetic flux density, N is the number of coil turns, I is the current flowing through the coil, and L is the magnetic path length. From this equation, we can understand that increasing the number of coil turns or the current will produce a stronger magnetic field, resulting in a greater lifting force. Now, let's look at the system design. The main controller of the system is the Arduino Uno. A joystick module is connected to the Arduino and is used as the input device. When the user moves the joystick, the Arduino receives the signals and processes them. The Arduino then controls two servo motors. The first servo motor moves the crane base left and right, while the second servo motor moves the arm and up and down. This allows the crane to position itself accurately above the metal object. At the end of the arm An electromagnet is installed. The electromagnet is powered by an external DC battery supply. When electrical current flows through the coil, a magnetic field is generated, allowing the electromagnet to attract and lift ferromagnetic materials such as iron nails and metal clips. The operation flow begins with joystick input. The Arduino processes the command, the servo motors move the crane arm, and the electromagnet performs the lifting and releasing process. The design successfully combines an Arduino control, servo motor, movement, and electromagnetic lifting into practical materials handling system. Thank you.
Hello, my name is Mohammed Ahmed Saeed. My matric number is AE2400070. I will present the results and discussion. So I will present inside the video of a demo demonstrating the prototype. The prototype consists of an Arduino Uno joystick module, two servo motors, and electromagnetic fabrication by welding copper wire around the steel screw core. The Arduino is powered separately through the pair jack, while the electromagnetic is supplied by the 209-volt battery. The joystick is used to control the movement of a cane. One servo motor rotates the can base while the other moves the arm up and down. While the electromagnetic is energized, it generates the magnetic field through the attract and lift the ferromagnetic object such as a paper clip and screws. Once the power supply is disconnected, the magnetic field disappears, allowing the object to be released to the desired location. The prototype operated smoothly and successfully lifted small ferromagnetic objects. The experiment verified the electric current flow through the wood core produced a magnetic field capable of generating sufficient lifting force that demonstrates the practical application of magnetostatic principles in electromagnetic material handling system. In conclusion, the electromagnetic cane prototype successfully demonstrated the relationship between the electric current and magnetic field generation, highlighting the effectiveness of electromagnetic in controlled lifting applications. Thank you all.